Good morning and welcome back to this rainy day. We have one more lesson to do to finish the review for systems of equations, working towards the test which will be this coming Friday, the 19th of June. So we'll get started. In the first part of the review, we looked at the three different ways that you can solve a system of equations. We said there was a graphical way, either by taking out your very own piece of graph paper and sketching the graphs. That is useful if you have a piece of graph paper. You can also use your graphing calculator, which is a little simpler, but also requires that you put your equations into slope-intercept form. So there's that extra little trick. You also have to sometimes mess around with the window settings in your calculator in order to see the lines actually crossing, because remember, your standard window setting only goes to 10 in your four directions along the x and y axes. The second way we looked at was solving by substitution, which also involves isolating a variable first, and then once isolated, substituting the value for that variable into your second equation to get an actual value for one of your variables, and then taking that value, subbing it back into an equation to get your second variable. And then finally there was elimination, the third way. And elimination involves making the coefficient of one or the other of your variables, your x or your y, making that coefficient the same by manipulating the equations if need be through multiplication. Once that's done and you have a coefficient the same on your x's or on your y's, writing the equations in the same order and then just subtracting or adding again to isolate a variable. Okay? So those are the three ways. What we're going to do today is we're going to use those three ways to solve word problems. Okay? So just generically, when you're solving any word problem, remember your first step is simply to comprehend. In other words, read through the problem and make sure you know what's going on, what's the problem asking you to solve. Okay? Now, for these systems word problems, the second step, and the second step generally, is to identify your variables. So in other words, when I say identify your variables, in most of these, there we go. In most of these word problems, they'll tell you what the variables are at some point, or it will be fairly apparent, okay? Usually if you look at the last sentence in the word problem, that gives you a pretty good idea of what your unknowns are, okay? So identify them and identify them clearly, okay? Write down, let x equal whatever, the number of concert tickets purchased, okay? If the problem isn't asking you for number and rather it's asking you for the price, you would say, let x equal the price of each concert ticket. So don't just write concert ticket. Make sure you identify clearly what your variable represents. That will help you with the next step, which is to derive or set up your equations. So you're going to have two equations. You'll find that, you may not believe this, but most of the word problems that that we introduce you to in this unit are relatively simple, okay? But you derive equations. Generally, if you look back to the word problem, it will kind of describe a situation involving the variables, and then it will describe a second situation involving the variables. And, that's part of the comprehension part. Part one is you need to be able to realize what are these two situations we're talking about. Usually one of them is quite simple, one of them maybe requires a little more thought. Okay? And then once you've derived your equations, You just choose whichever way works best for you or whichever way you've been instructed to use, either graphing, substitution, elimination, and go ahead and solve. Okay, so your fourth step, solve the system. Make sure that you know how to do the fifth step. I'm not going to focus much on it in this review because we're limited for time. And that is, remember, you should always be able to verify. Okay? And remember, verifying simply means taking your solution, your ordered pair where those two lines cross, taking that solution, value for x, value for y, plug it back into your original equations, both of them, and make sure that the left side equals the right side. Okay? We'll get started. So, the first one says, that's terrible. Sales clerks at an electronics store have a choice of two methods of pay. Plan A weekly salary of $450. So, you don't have to sell anything. You still get $450. However, if you do sell something, you kind of get a bonus. In this case, it's called a commission. Remember, we talked about commissions in 10-3. A 3% commission on all sales. So you've seen this sort of a situation before. Plan B, which some people call you only eat what you kill, meaning if you don't sell anything, you get $0. Okay? You starve. So, straight 7% commission on all sales, no base salary. Okay, so two plans, two equations. Okay? Create a system of equations to model both plans. Okay, well, what are our unknowns, right? Identify your variables. Well, we don't know what our sales are, but we know that they will affect how much we earn. And our second variable is how much do we earn? Okay? So, let's call it P equal pay per week. Notice you want to identify your variable clearly. And we'll say let S equal sales per week. Okay, so we've clearly identified our variables. Now we have to come up with a system of equations, two equations. In this case, one that would describe plan A, one that would describe plan B. Okay? So, for plan A, our total pay is equal to $450, which we get no matter how much we sell. It's a base salary. And to that, just let me move this silly little cursor. There we go. And to that, we get a 3% commission. Now, it's 3% of all sales. So, remember from 10-3 math, we never use percents in an equation. We always convert to a decimal. To convert from a percent to a decimal, remember you divide by 100 or move the decimal 2 places to the left, as I've done here. 0.03% of sales. How about plan B? Plan B is a simpler equation. Our total weekly pay is simply made up of our 7% commission multiplied by our sales. Okay? So, here's our two equations. How many sales must be made for the two plans to be even in value? Solve graphically and ensure to sketch the graph and state an appropriate window. Okay? So, we're going to go to our graphing calculator now, and we're going to graph these guys. So, graphing calculator, hello. Now, hopefully you're getting fairly familiar with this. Remember, we go to our y equals button in the upper left-hand corner. We get rid of any equations that are in there by pressing the clear key, cursor down, press clear again, and we enter our new equations. Our first one, we've isolated it for our dependent variable, P or Y, and it's 450 plus 0.03s. So plug that in, 450 plus 0.03, hit the variable button, which is in the upper left-hand corner as well, 0.03x. So there's our first equation, cursor down to the next line. Plug in our second equation, the simpler one, which is just 0.07 times the variable s. Here's our two equations. In order to see the graph, we press graph. And we wait. And we wait some more. Oh, there's one. And we won't wait any longer because you won't see the other one. Okay? Let's take a look at this equation. Our first equation, 450 plus 0.03s. That 450, remember, from chapter 7, that's the y-intercept. Now, our graph only goes to a y value of 10. So, it's not that the line isn't there. The line is way up there somewhere, kind of beyond the roof and up into the sky. So, we're going to have to change our window setting to bring it back down. So, if we have a y-intercept of 450, we've got to have a maximum y value of greater than 450. Otherwise, we'll never see the line. Now, I would suggest, now you want to go to your window setting, which is right beside y equals. I would suggest you set your y max at double the y-intercept. So set your y max at 1,000, okay? These are just, they don't have to be exact. As long as you get something big enough to show 1,000, to show your lines crossing. And it's also kind of a guess and test thing. So we've reset our y max. Let's press the graph again. Now we'll probably be able to see both lines, but as you can see, we can see them now. There's our plan B, which crosses at 450. These lines almost seem to be parallel. Now they're not really parallel, but they will slowly and slowly get closer and closer together on this side, right? Remember, this is positive x values or sales, but it's going to take a long time. So we're going to go back and we're going to play with our window settings again. And this time we want to get an X max that is way bigger than 10, because you're going to sell way more than $10 worth of stuff, right? Let's set our X max at 10,000. And again, this is just a guess and test thing. And sometimes you've got to mess around for a while. So we'll press graph again. Now with an X max of 10,000, you see that the graph has changed quite a bit. And you see that we almost made it. So 10,000 isn't even big enough. Let's double it. Let's try 20,000. So go back to your window, go back to your X max, and make it 20,000. And see if that's big enough. Press graph. There's our one line for plan B, and the other line for plan A, and we're good. Okay? So, once we have that intersection there, we can go and find what the actual values are. And remember, you have to go second and trace. That will give you your options. You want option 5, the intersect, so press 5. And it says, is it on the first curve? You press enter. Is it on the second curve? Press enter again. Do you want me to guess? Press enter one more time, and look at that. It gives you your solution, which is an X value of 11,250 and a Y value of 787.5. Now, before we go any further, let's refer back to our variables. Okay? Our S, or independent variable, sales, tells us you have to sell $11,250 worth of electronics equipment in order for both plans to be the same. Remember, the intersection point is where they're the same. And your earnings, your independent variable or your pay per week, means you will earn $787.50. Okay? We'll go back to our problem. Before we do that, let's just go back to the window. It had asked you for an appropriate window. Now, an appropriate window has X minimum of -10. You could set it to 0 if you wanted to, because you can't sell negative amounts of equipment, but you can leave it there. Your X max is 20,000. Okay? The scale just tells you where those ticks are. And maybe we'll just take a second. If we look at our graph again, you'll see there are no ticks, right? That's because, remember, we're going from 0 to 20,000 along the X. You couldn't put 20,000 little ticks there. That's because you've set your scale at 1. That means this poor calculator is going to try and put a tick for every 1 that you go up. Well, there's no way it can put 20,000 ticks along the x-axis. However, if we were to change our x scale to 1,000, and I'm not going to change the y scale just to show you how they will look different. Let's graph it. And look, now your calculator knows. If I put a tick for every 1,000 I go up, then you can see it. There will be 20 little ticks along here, right? From 0 to 20,000, if there's a tick every 1,000. My y-axis I didn't change. Notice it just gives me a really thick line. What that tells you is the calculator's trying, but it can't do it. Okay? Anyways, there we go. So a reasonable window would be -10 or 0 to 20,000 along the x-axis, and -10 or 0 again, because you can't get paid a negative amount, to 1,000 on the y-axis. That's totally fine, okay? Any window that puts your intersection somewhere kind of in the middle is just great, okay? Let's go back to our lesson. So it says, how many sales must be made for the two plans to be even in value? Well, look, it's right there. Okay, $11,250 in sales will result in pay of 700 and, whoa, remember it's Monday, $787.50 for both. If a person averaged weekly sales of $20,000, which plan should he choose? Now, go back to your graph. So it says, there we go. It says, if you sold $20,000, which remember is right here, which plan would be better? Well, take a look. Which line is higher? And you kind of have to imagine, but this line would keep going here, this line would keep going here. So at $20,000, this red line is going to be way higher, right? What that means is that red line will result in a much higher pay. That red line will result in a much higher pay. And that red line corresponds to, well, that's interesting. The red line corresponds to your pure commission deal, okay? The 7%. So let's move on and take a look at a couple more different types of word problems, okay? Okay, so let's get rid of this so you can read. It says, Claire produces scented candles. The cost of producing a candle is $1.25. Claire sells a candle for $2.50 and has startup costs of $300. Let X represent the number of candles Claire sells, R represent the revenue, and E represent the expenses. Okay, I think we're going to skip this one. This one is a little more difficult and not like any that you will see. This one you definitely will see. Okay, so Steve invested $7,000 for a year, part at 9% interest and part at 6% interest. After 1 year, the total interest earned was $540. How much did Steve invest at each rate? This last sentence is very important because it gives you an idea of what your variables are going to be. They want to know how much did he invest at each rate. So we're going to say let S equal the amount invested at 6%. And we're going to say let N equal the amount invested at 9%. Okay? So we have two different amounts. And that's what they're asking us to figure out. How much did he invest in this account? How much did he invest in that account? Okay? Now it tells you the total amount he invested, and you know that that total amount is made up of the chunk he threw in this account and the chunk he threw in that account. And that gives you your first equation, kind of the simpler one, right? So we have our amount invested at 6% plus our amount invested at 9%, all together equaling $7,000. Okay? That's our first, somewhat more simple equation. In these sorts of problems, your second part, your second equation, comes from considering the interest. Well, he's going to earn 6% interest on this blob of money. So to figure out that amount of interest, you would go 6% interest multiplied by the amount of money in the account. For a 9% account, a similar term results, except remember, since it's a 9% interest account, we're multiplying our variable by 0.09. Okay? So when you take the interest earned in the 6% account, add to it the interest earned in the 9% account, all together, you get a total interest earned of $540. There are our two equations. Okay? So now that you have your two equations, it's just a matter of finding out where they intersect, right? Solving the system of equations. Now, I'm going to use substitution for this one because this first equation lends itself easily to isolating the variable. I'm going to isolate S, and that will give us an equation of S equals 7,000, minus N. Okay, I've just subtracted N from both sides to isolate. Now that I have an expression for S, I'm going to take that expression, I'm going to plug it into this equation where I see S. So this equation will become 0.06 times our expression for S, 7,000 minus N plus 0.09 N equals 540. Again, I've just substituted this expression for S. Okay? Now it's simplify time. So we'll take our calculator, and remember you're distributing 0.06 over both of these, and that will give you 0.06 times 7,000, 420 minus 0.06 N plus 0.09 N equals 540. continue to simplify the left side. These are like terms and can be combined. That'll give you 420 plus 0.03 n, I've just added these together, equals 540. Now that we've simplified the left side as much as possible, what we need to do is isolate n. So we're going to subtract 420 from both sides. That gives us 0.03 n equals 120, right? 540 minus 420. And then our last step is to divide both sides by 0.03. And that gives us n equals 4,000. So what does that mean? That means, here's our solution. We'll just put them in alphabetical order. So we'll say n is our first variable. Sometimes it doesn't matter. N is our first variable and is $4,000. Take your value for n, sub it back into either equation, and solve for your other variable. Now, I'm taking this first equation because it's way easier, okay? So, we take our value for n, we sub it into s plus n equals 7,000. That becomes s plus 4,000 equals 7,000. Isolate s, subtract 4,000 from both sides, leaving you with s equals 3,000. So, our value for n is 4,000. Our value for s is 3,000. Okay? I think we have time for one more question. This one is pretty much the same as the last one. Let's see if we can find something. Let's try number 11. Number 11 is a little bit trickier, not terrible. And it is asking us to solve by elimination. So, for this one, it says, Richard's Rainy Days Be Gone manufactures two types of umbrellas, regular sized and golf. A regular umbrella costs $5 for the actual materials, and then another $18 for labor to actually turn those materials into an umbrella. Okay? One golf umbrella costs $7 for materials, so a little bit more for materials, and $25 for labor, again, a little bit more for labor. Okay? So we're breaking the manufacture of this object, an umbrella, into how much you pay for your materials and how much you have to pay to actually make it for your labor. Richard's budget is $3,100 in total for materials, so the regular umbrellas plus the golf umbrellas, he can only pay that much for all of his materials. Similarly, he can only pay $11,100 for all of the labor, regular umbrellas plus golf umbrellas combined. Solve to find out how many of each type of umbrella can be produced. So again, that last sentence tells you what your variables are. Okay? So, let's say let R equal the number of regular umbrellas. Notice that I put the number of. We're not trying to find what the final price is for these regular umbrellas. We're trying to figure out how many can you manufacture. And similarly, then we'll say let G equal the number of golf umbrellas. Okay, you don't have to pick R and G. I just did it to remind myself which variable is which, right? R for regular, G for golf. Write an equation for the total materials. So, the first thing we're going to look at is the materials. So, our regular umbrella is $5 for materials. So, if I want to just make one umbrella, that would be 5R, right? $5 times one umbrella. What about the golf umbrellas? Well, the golf umbrellas, the materials cost $7. So, the total cost for materials for my regular umbrellas is $5 per umbrella times the number of umbrellas. Similarly for the golf, $7 per umbrella times the number of umbrellas. And the total amount I can spend for materials is right there, $3,100. A similar equation for labor becomes 18R, right? Because it costs $18 for labor on each umbrella, plus 25G, because a golf umbrella requires more labor, $25 per golf umbrella, and I have a total of $11,100 that I can spend on labor. What do you know? We have our two equations. Okay? Solve the system using elimination and determine how many of each can be produced. So, we've got a couple of equations here that don't really lend themselves all that nicely to elimination, okay? However, if we were to multiply this first equation by 5, that would give us 90 as our coefficient of R. And if we were to multiply this equation by 18, that would also give us 90. Making the coefficient of R, the same in both cases, that's the way we're going to go. So, 18 times 5 will give us 90R. 18 times 7 will give us, what, 128? G, let's make sure, 70 and 56, yes. And 18 times 3100, I'm not even going to try. It's 55,800. Coming down here, we multiply through by 5. That gives us 90R, 125G, and I'm not going to bother. $55,500. Okay. Next step, subtract your equations one from the other. That gives us 90R plus 128G equals 55,800. 90R plus 125G equals 55,500. Since we have positive values for both of our R variables, that means we have to subtract to make it disappear. 90 minus 90 is 0R. 128 minus 125 is 3G. We're not going to bother with that. It's a 0. And 55.8 minus 55.5 gives us 300. Isolating G, divided through by 3, gives us G equals 100. Okay? So our solution, and again, we'll just place them alphabetically because it doesn't really matter which is our X and our Y. Our G value is 100. Last step, solve for our R value. How many regular umbrellas? Plug your G value into either equation. I'm going to use this one because the numbers are smaller. Okay? So I'm going to plug G in here, and that will give me 5R plus 7 times 100 equals 3,100. 5R plus 700 equals 3,100. Now we want to isolate R, so we do the subtraction first. Take away 700 from both sides. That gives us 5R equals 2,400, right? 3,100 minus 700. And finally, divide through by 5, and that will give us R equals, what is that, 96? 960, 9600, 960. 2,400 divided by 5. Thank you, Mr. Calculator. 480. So, our final to finish the problem is simply to say in a concluding statement, we would need, or we could make 100 golf and 480 regular umbrellas. Okay? And we're done. Now, it takes a long time to do these problems, so unfortunately I wasn't able to do too many with you. Hopefully this gives you a little bit to go on. Remember, you have all of those practice problems as well. Take a look at those. Look at my YouTube videos on solving the practice problems. That's 8.4 in your assignment booklet. That will give you some other examples of solved problems. Good luck. Your test is Friday. This will be the last YouTube video I post. There will still be review sessions every other day. So we've got a couple of review sessions as well to go through. Anyways, good luck with your test on Friday, and see ya.